For the listeners that might not be familiar with the term structural monitoring, can you explain what it means and the benefits it holds for public infrastructure owners?
I want to explain this in the context of bridges, where this application really started. In around 1971, the Federal Highway Administration required bridge owners to inspect their bridges biennially, every 2 years, using visual inspection. After about 30 years of this, when everything seemed to be going well, the Federal Highway Administration did a study about the efficacy of visual inspection. They took 50 bridge inspectors, randomly selected.
Considering bridge safety, we typically prioritize regular inspections and maintenance. However, there's an alternative approach to ensure the safety and integrity of your bridges without the need for frequent manual checks. It's where structural monitoring technology comes in, a game changer for bridge owners aiming to maintain their infrastructure in top condition. In today's episode, I'm joined by Peter Vanderzee, President and CEO of Lifespan Technologies, a pioneer in structural monitoring. He'll be sharing lessons learned from his 2 decades of experience, including the challenges and breakthroughs of introducing new technology to the public infrastructure sector. With that, let's jump into today's episode. It's now time for our conversation of the week with Peter Vanderzee. Peter, welcome to the show, and thank you so much for taking the time.
My pleasure, Nick.
Excellent. So I know we've got a lot to talk about today, so we'll jump right in. So Peter, can you start by sharing a bit more about yourself, your company, and how you became involved in structural monitoring technology?
It's an expansive career, I'll say that, but I started with a very broad-based engineering education, both mechanical engineering and industrial. They were both helpful for me, in especially in terms of being an entrepreneurial kind of guy, that having a broad background is really a plus. And when I got started with this, I had a very broad background in terms of various industries and various positions in industries. Many of the assignments that I had were brand new, that nobody had ever done them before. And it gave me an opportunity to learn about a whole bunch of different functions within a company, from sales to marketing to operations, strategic planning, financial, and so forth and so on. So I had a really, really strong background with all of that before I got involved with Lifespan. But the Lifespan company and relationship started out with a firm that was located here in Atlanta, and they had a sensor that was patented, and they had no idea how to sell it. They thought they were going to sell it to bridge owners, but they really didn't know what they had, and they didn't have a marketing plan or anything else to launch with. So they asked me to do some consulting with them, which I did, and they eventually asked me to run the company. So that was almost 22 years ago, and it's been fun ever since.
Beautiful. Great way to get us kicked off, Peter, and letting the audience know kind of the origin story and how this all came about. But for the listeners that might not be familiar with the term structural monitoring, can you explain what it means and the benefits it holds for public infrastructure owners?
I want to explain this in the context of bridges, where this application really started. In around 1971, the Federal Highway Administration required bridge owners to inspect their bridges biennially, every 2 years, using visual inspection. After about 30 years of this, when everything seemed to be going well, the Federal Highway Administration did a study about the efficacy of visual inspection. They took 50 bridge inspectors, randomly selected, brought them into Washington, D.C., and had them look at 3 bridges that they knew exactly what was wrong with these structures. They took all the results, tallied them up, did some statistical analysis with it, and they found 2 things that were extremely important to them and certainly to us. And that is that the inspections were very subjective, which is not surprising, and very conservative, which is also not surprising. That's actually a good thing if you're inspecting a bridge, to be more conservative. However, That leads to difficulties that the owners faced after that of if my bridge is rated poor, should I replace it or do a major repair? And if they were overly conservative and my bridge was actually good, I'd have to spend a lot of money when it wasn't necessary. So that was the genesis, really, of structural monitoring, the use of sensors, various sensors, and the ability to capture a lot of data and put that in a very secure website, present that data to the owners or the owner's engineers or both, so they could get a more objective, more timely, and more accurate assessment of the condition of their bridge. So the business itself has been ongoing for almost 25 years right now, and I think the future looks still pretty bright for continued growth.
And did you anticipate that introducing structural monitoring technology to bridge owners would be a straightforward process?
I would like to think so, Nick, but having worked with government agencies before I ever started Lifespan, I knew this would be an uphill battle, and it even continues today after a good 20 years. I'm sorry to have to say, but government is typically the slowest adopter of new technologies. That's just inherent in their organization and how they operate. So consequently, we structured a Lifespan to minimize our overhead and kept our expenses very low during this excruciatingly slow adoption process, which worked to our benefit. We did not have to have any third-party investment, which reduced the stress on us of having not to produce instant results. So it's been a good journey, and I think we did a lot of things right, but it has taken a long time, and it continues to be a bit of a struggle.
And with what is a long sales cycle and just a generally a long time from inception to actually getting the product used, how did you get approval for the first few projects?
Well, a little bit of luck goes a long way sometimes. As soon as we started the company, and if the word got out, we had a call from an engineering firm in Raleigh, North Carolina, that resulted in us within a month or two of putting in a structural monitoring system on a parking garage, of all things. And that got us kicked off. And our second project was in Pennsylvania, and we had a board member who was the former chief structural engineer for Federal Highways, since retired. He joined our board, and he had great connections. He and I visited with the Pennsylvania Turnpike Commission. We had a face-to-face meeting, and he convinced this chief structural engineer to try this technology on one of his bridges. So for the first project with the parking garage, we were fortunate. The second one occurred because we had a personal connection. And, after that, they started to come in dribs and drabs. Then they started building momentum. And today, we get calls from engineering firms and owners simply because we have a reputation in the market now. We've done a lot of work across the country. People know us, they trust us, and when we get these calls, we carefully decide whether we want to actually work on these projects. We have become very picky in terms of what projects we do. We don't chase projects that are outside of our wheelhouse. We try to stay with projects that we're really good at, and it's been very successful.
And how's your approach to selling the technology evolved since you first started? Because I imagine it's different when you've got a roster of clients and case studies versus when you were just starting out about 25 years ago.
Yes, indeed. As I mentioned, we benefited early on from intervention by certain people and a little bit of luck involved as to how we got that first project in particular. But, you start to build a track record. And we have continued to build our website, added projects, example projects that would inform people that came to our website and would understand the kind of work we do. But today, we're really relying on engineers and owners of structures who have heard about us, our successful projects, taken the time to look at our website, and then frequently call us and say, would this be something you could do? Are you interested in doing something like this? And if it fits the criteria that we really like to have for the projects we execute, we continue on the discussion, and everything generally comes to a very satisfactory conclusion.
Well said. And what did you learn from the first few projects that you then subsequently incorporated into your marketing and sales pitches?
Well, after that Federal Highway Administration study came out, and after the first few projects we did, we confirmed that visual inspection was overly conservative. And we found that most structures, and when I say most, I'm talking well over 75%, were in better to much better structural condition than presumed from visual inspection. That was a huge, huge wake-up call for not only us, but I think for the customers that we were discussing projects with and continue to do that with. So knowing that, we determined that this application could provide a robust return on investment for the owners if it was used judiciously. And I have been of the opinion that's shared by many, I think, that are in the technology business, that if you're not getting a return on investment, you really don't have a business. You're giving a return on investment to your clients and customers. So for 10 years going, we hammered the media. We were writing stories, getting them published in the print media, on radio, technical conferences, and so forth, highlighting our ability to deliver a return on investment by safely deferring unnecessary repair and replacement projects. And consequently, this is our service mark that we started right at the beginning of the company, safely extending asset life. The word safely is critically important, and asset life fits in nicely with asset management programs. So that's what we do. That's what we've been successful at, and that's what resonates with owners.
Well said. And that safety piece is critical. And like you had mentioned before, visual inspection being conservative isn't necessarily a bad thing from a safety approach, but from a dollars and cents approach, it definitely leaves a lot to be desired.
Absolutely, Nick. And those two objectives have to be balanced. I would lean on safety being by far the most important, but once you cross that bridge, no pun intended, you really have to start thinking about dollars and cents. And the client or customer in this case is very, very aware typically that, they don't want to spend a lot of money on this. So whatever money they invest in monitoring systems, it's helpful to guide them towards a return on investment. And when they get that, they're very happy.
Yeah. And I think a great, use case that we've talked about for both owners and then users of public infrastructure, right, is getting a bridge posted, which, Peter, could you just explain what that means in kind of layman's terms for the audience?
Yeah. There are about 620,000 bridges in the United States, and approximately 60,000 of them, almost 9% or so, even a little more, are restricted in the amount of weight that should use the bridge. And I think everybody that's driven a car is familiar with this road sign that says load limit 10 tons, 20 tons, of that nature, when they cross a bridge. Now, most of these 60,000 load-restricted bridges are owned by local governments. They're called off-system bridges, meaning the state DOTs are responsible for the interstate highways and the major state arterials in their state. But the local owners typically own smaller bridges, often under 150 feet in length, and they're the ones that are bearing the brunt of these load-restricted bridges. And it creates all kind of headaches for them, mainly because it affects the users that can travel the bridge, whether it be truckers that have heavy loads, whether it be farmers that are taking crops to the grain silos in the Midwest, whether it's first responders, a heavy fire truck, for example. And there's even been cases where school buses couldn't use bridges and they have to take detours. And for example, farm equipment, it may cost farmers $3 a mile to run their farm equipment around a detour. And if you're in the Midwest and you have a 20-mile detour and you have to take it both ways, that's 40 miles times $3. That's like extra $120. And that comes right out of their pocket. So there's a lot of pressure put on the local owners to remedy the problem. Now, the issue really with local owners and posted bridges is they don't have the depth of knowledge on how to solve that problem. So, we've come along and said, hey, we've got the ability to conduct load tests on these bridges. And when we do, at a relatively low cost, we find that 60 to 70% of the bridges that are tested can have their restrictive load ratings or load limits removed. That, if you're a local owner and you're looking at a $1 million project to replace a bridge, and as a result of this load test, you don't have to, they get very happy really quickly when they don't have to spend $1 million unnecessarily.
And to just summarize, Peter, when we're talking about the biannual every 2-year inspection program, federal highway mandates, it's done visually. Studies have found that it's typically conservative, not in all cases, but in the majority.
Right.
And Lifespan's coming in and saying we can provide that engineer of record and the inspection team the peace of mind backed by data that there are alternatives to posting a bridge and making end users travel all sorts of detours, et cetera, and basically stating, hey, our sensors may cost X, but your return on investment is going to be multiples greater by deferring or eliminating, in many cases, major repairs or replacement.
Absolutely a good summary, Nick. And just to put some numbers on it, it may cost a local owner anywhere between $20,000 and $30,000 to conduct the load test with the analysis and submit that to their state DOT. But the average price for, say, a bridge replacement is probably north of $1 million. So if you can spend $20,000, $30,000 to avoid replacing a bridge unnecessarily that was $1 million, your local taxpayers get real happy. And, if you're a public works director, you might get a raise if you pull that off a few times. So it's really good for those guys.
$20,000 of investment in a monitoring program is, on a $1 million replacement is literally 50 times return on your money, which I don't think anybody's going to be too upset about, right?
No, they get very happy very quickly.
And Peter, actually speaking to the data piece, so over the past 25 years, what have you learned about data transmission, secure storage, analysis, and then the final presentation to your clients?
Well, none of our customers have ever been concerned or asked any questions about the scheme that we use for data transmission and storage. Very simply, we're using the cell network that's available to us. And secure storage would be like someone with that, like Amazon Web Services, that offer that to all kinds of industries today. We've never had questions, and we've never had problems with that. We have upgraded our presentation software over the years and making it easier for our customers to understand. We typically offer them simple graphical summaries of the strain or displacement readings or even inclinometer readings on their structures. Been very, very helpful. The thing I want to interject here, though, is, and this is really critical, we were the ones, our company was the first ones that I'm certainly aware of that separated thermally induced strain from live load strain. Sensors can't tell the difference between thermal strain and live load strain. They only know strain. But given the fact that you cannot control thermal strain, when you take the thermal strain out of the total strain readings, what we're finding is that the strain values caused by live load on bridges and other structures is substantially less than you would think otherwise, and oftentimes well below design parameters. So that, again, suggests that structural engineers are doing a really good job if they follow codes to design bridges and other structures, and that the live loads anticipated are probably less of a problem than anybody ever thought. It's a revelation. It's proven to be very, very important for our customers.
Which is excellent, because and there's a piece to be said about over design, which to this discussion isn't incredibly relevant, right? Because the bridge is in place, it's in service, and there's nothing we can do to change that. But the fact that you're able to find that is really encouraging, because even if, let's say, there's more material degradation or other problems, right? It sounds like there's more excess capacity here than we would have originally thought.
Indeed. This factor of safety that's used for bridge components and, the whole bridge itself is substantial. And that's a good thing. I mean, it probably costs a little bit more to do it with a high factor of safety than you could get away with. The safety is enhanced greatly, and it helps extend the service life of the structure. Whereas the original thinking on bridge service life, or design life, I should say, has been 50 years. Today, we're designing bridges with a theoretical design life of 100 years. But, the information that we're gleaning from monitoring and working with structural engineers would indicate that this 50 years of theoretical life from an old bridge is very easy to exceed. And getting 60, 70, and even 80 or more years out of a bridge is very possible within safe limits, without exceeding overloads or anything that would compromise safety.
And that's an important piece, because although a bridge may still be, standing after 70 to 80 years, that piece of safety and not overloading the structure, because even though you might be able to overload a structure immediately in the near term, nothing catastrophic may happen immediately, but that could be a different case long term, I presume.
Yes, it could. There's a failure mechanism called fatigue, and if you have enough cycles of heavy overloads that exceeds a minimum amount, or I should say a maximum amount over those cycles, that could cause a fatigue failure. But that's fairly rare. We're talking, way less than 1% of all the structures. So monitoring itself, we're able to capture the strain data and the strain histories, and, we would know if a bridge is heading in that direction, which gives the owner a whole lot more time and comfort to know that they can provide a remedy by either a major repair or even start the replacement process in a timely manner, and not having to do this on an expedited or emergency basis.
In this past couple of minutes, Peter, we've been speaking about, right, the structural engineering and the mechanics and the technical, but how do you ensure the data collected is effectively analyzed and presented in a way that resonates with infrastructure owners, right? Like, how do you make them care?
Well, the important point here, Nick, is that we are not doing the analysis. We are working with highly competent engineering firms, probably 95% of the time, where their structural engineers, the better ones on their staffs, have 30 to 40 years of experience. And, we'll work with them to be sure they understand the data collection, the data presentation that we do, the separation of the thermal and live load strains. But what we find is that if we're working with people that have that kind of experience, they're very careful, they're diligent, and they have enough varied experience that they're able to ask good questions about the work that we've done, such that it gives us confidence to know that they are doing the best job possible. And on top of that, these big companies that we work with, mostly the major international AEC firms, have an enormous amount of insurance coverage if they do have a mistake. But, they're not going to let their people take unnecessary risks. They're constrained in that way to act within parameters that would absolutely and positively ensure safety for the traveling public and provide very, very sound analysis for the owner.
Well said, Peter. And how do you foresee the future of structural monitoring and its role in public infrastructure projects?
Nick, we still have holdout. I call them holdout owners. Go do this in 49 other state DOTs and then come to me. Innovation in government service or government employees, typically don't fit in the same paragraph too well. But I don't mean to be hard on them, but they're just not, in many cases, just not willing. And I have found a number of cases of interest maybe to the listeners. The younger staff members, the ones that have graduated in, say, the last 10 years from curriculum instruction, structural engineering, have had coursework in the use of sensors for monitoring. They are very comfortable with digital technology, with the electronics and the cellular communications and secure storage and data warehouses and on and on and on. They're very comfortable with that. But when they go to their boss, who started engineering school with a slide rule, they're very hesitant. They don't want to go down that road. And typically the older guys are, 4 or 5 years away from retirement. They don't want to mess that up in any way, shape, or form. So there's always that dynamic that exists. But over the last 10 years, I will say that we're seeing more and more of these young engineers taking positions now of substantial authority. And the older guys are retiring en masse. The baby boom generation, they're retiring after 30 or even more years of service. The younger folks are coming on, and it's making our job a little bit easier. I will say, though, that I think the future of this, to go right to the point of your question, we're still going to see this application focused on bridges, but there is a movement now towards other infrastructure, such as old buildings, parking garages, and other structures where more objective, more timely, more accurate data will lead to better financial decisions by the owners. Now, I don't think it's likely that any of the new infrastructure that we see will see a suite of sensors installed at the same time they're constructed. I've never been able to understand the economics of that because, again, as we spoke earlier, bridges are significantly over-designed, and that's a good thing. So is there going to be much degradation in the first 25 years of service? Probably not. But the exception, and there is an exception here, is on new signature bridges that cost $1 billion to $5 billion to build. That makes sense to put a suite of sensors on. And when I say a suite, I'm talking 100 to 400 sensors. The problem, however, comes to does the owner have someone on their staff who will dive into the data and be responsible for the analysis of that data? And in recent conversations that I've had with the New York State DOT, the New York City DOT, and the New York City MTA organizations, their chief structural engineers have told me that's their biggest concern today, that they think they're going to get overwhelmed with data if they use monitoring systems, and they do not have the staff capability or even the numbers of staff today that can do a very good job, like they should do, on analyzing the data that's captured.
I guess an alternative for those organizations could be, as an example, for every 2-year inspection cycle, if they want to write it into their specification, is interpretation of monitoring data.
Absolutely. We see that a lot, Nick. And that, again, not surprising. They're these organizations are responsible. Those ones I mentioned in New York City, they're responsible for, scores of bridges. Many of them are signature structures. They can't possibly lose them out of service. You can almost never repair them because the disruption in a place like New York City would be incredible. The same would, be for Chicago or Boston, that has old infrastructure. So, there's people out there that can do a great job of interpreting the data, but again, we're finding those people are not 25 years old. They tend to be 45, 55, even 60 years old with extraordinary experience, seen a lot of different things with structures, including buildings, parking garages, and so forth. Those are the people that are really good at this and the ones that the owners need to employ.
And like I've always said, and we've talked about, Peter, sometimes the best combination is, let's call them the young guns that are, graduated within the past 10 years who comfortable with the digital technologies, combining that with the experience of the practicing engineers with 20, 30, 40 plus years of experience, right? I think it makes a great combination because each is learning from the other.
I couldn't agree with you more, Nick. And what a great way for the older guys or guys and women to mentor the young ones and bring them along. This technology has been very impactful. It's saved millions and millions of dollars for a lot of different owners. And if anything, it's going to continue to be used on more and more structures. And the ability for the older engineers to mentor and teach and, support the younger ones, I can't think of a better scenario than that.
Well said. And Peter, thanks again so much for taking the time today. What final piece of advice would you share with engineers and professionals in the industry that are looking to innovate and introduce new technologies in their field or niche?
That's a very good closing question, Nick. I think that first thing is to recognize that even though you may be convinced that a certain technology or innovation is technically sound and can provide a significant ROI to your customer base, it's going to take a substantial investment in time and money to bring that to the realization of those people who sign checks. And you have to get to the check owner. It's one thing that, to have a young engineer tell you that this looks like the greatest thing he's ever seen, but he doesn't sign the checks. And you've got to get to that person eventually, and that takes a long time. So my advice there is that if you really believe in your innovation and you've seen it work and you have utmost confidence, don't give up, okay? It's just going to take a long time, and you have to plan for a long and expensive runway for widespread adoption. I have a thing I call the rule of home projects. You may have heard of this. Whatever you think the home project might take, Nick, it's always 2 and 3 times as long. Your trips to Home Depot, Lowe's, Menards are always twice as often as you think because you forgot this and forgot that. It's no different than anything else. This is the way it works, and you just have to consign yourself to it. But finally, if I was giving advice to a young entrepreneur who wanted to get involved in this business or something akin to this, avoid third-party investment for as long as you possibly can, or even completely if it's possible, because those folks will never understand your technology. They'll never understand the nuances of technology adoption, and they're only looking for tangible financial results in months, not years. So you could be on the outside faster than you think. And this whole thing is replete with examples I can give you. But when you bring in the third-party money, you're selling your soul, I wouldn't say to the devil, but maybe the next thing closest to the devil. And they're going to be pounding you all day long and 6 times after lunch on Friday. So don't think you're going to take Friday afternoon off, because you're not. And you're probably going to work Saturday and Sunday too. So again, be careful, know what you're doing, take your time, recognize this is going to take longer than you think. But if you really believe in it, don't give up. Keep pushing, because that's what it takes to succeed.
Peter, thank you again for taking the time to join us today. If the listeners have any more questions for you or anything we spoke about on today's show, what's the best way for them to connect with you?
I would entertain phone calls or emails. They can reach me at our Lifespan Technologies phone number, which is on our website. I'd invite people to go to the website. It's lifespantechnologies.com. And if they'd like to send me an email, it's Vanderzee, VANDERZEE, at lifespantechnologies.com. Always happy to hear from people who are interested in this technology.
Beautiful. So, Peter, it has been an absolute pleasure.
Thank you, Nick. Really appreciate it.
Absolutely, Peter. Take care.
Please remember, you can find the show notes for this episode at aectechpodcast.com. There, you will find a summary of the key points discussed in today's episode, as well as links to any of the resources, websites, or books mentioned during this episode. Until next time, I wish you the best in all of your engineering and technology endeavors. Thank you.